I am Jirat Thepara from Kasetsart University. For today, we have a keynote lecture, Professor Suttisak Soralump.
Dr. Jirat, thank you very much for your kind introduction. Today's topic that I'd like to discuss and give some thought to our young civil engineer is relating with the lowland earth excavation and filling problem. The meaning of the lowland city is a city that is very close to the sea level. You can see the area of the rice paddy field in Burma, in Thailand, Cambodia. These are all lowland cities. If we talk about the lowland city in Japan, I think as a soil engineer, we think of the Saga city. The Jakarta is moving their capital city to the new island. They plan and they already have the approval to move to Borneo Island. Basically, in the past, Jakarta used the underground water, so that may be the main reason that the subsidence or the settlement occur. I found this kind of flood wall. Sometimes the water or seawater overflow, that there are going to be some source of the climate change that causing the sea level that increasing up. That's the point of view of some other people. Let's see the point of view of civil engineers. What about the point of view as a civil engineer? Flood wall actually sinking because of its own weight. Okay, let's come to Bangkok or Thailand. This is the geological map of Thailand. This is the map showing the ancient shoreline. The people who live in this area in the past, they rely on the canal. And so in the past, they used canal for the transportation route. And then they live along the side of the canal, like this one. The first floor is elevated up. Almost 70 or 80 years ago, we start to have to change our life, to change our habitat. Now, instead of using the canal, we start to use the roadway. And then you need a dry land. So when you build the house, instead of using the house in the old style, as I mentioned, we try to filling up the soil over than the maximum flood level in the past. As I already mentioned, when we're going to build the house, we're going to ask around that was the maximum flood level in that area, and then we try to fill it up. But in 2011, the new high broke, high elevation, higher flood elevation. Also, that's why filling high even more. Like this one. You can see this is the house of the neighbor. Do you familiar this? Do you familiar what happened in Jakarta? That they're filling more soil into the area, and then they have ground subsidence not only from the groundwater pumping, they also have the ground subsidence for the weight of the fill material. Bangkok starting to build a dike in order to prevent the seasonal flood from the north. This is example of the flood protection wall of Bangkok. This is along Chao Phraya River to drain the water from the lowland area, and we need to build the water bank. After 200 years, we have the layers of soft clay above. This is the map showing the subsidence rate, and you can see this is the information of the piezometric level drawdown or the groundwater drawdown. For example, if the ground subsidence occur for 10 years, about 1 meter, when you stop pumping, maybe the recover of the ground level would be in millimeter units. Very small. And occasionally, for example, in 2011, when the big flood happened, heavy rainfall in the north, and then this dike cannot hold the large amount of water, so it's blocked. So this what happened in 2011. The flood from the northern part of the country or the northern part of this lowland flood into this lowland and reclaim its area. This is our campus in 2011. Before we start any project in the lowland area, we need to fill in the soil in order to elevate it up. And then we start to do the piling and then build the house. We need to use pile foundation for the houses, and until up to the high-rise building, we need to have the piles like this. This is the fill soil. And then we pile for the house and we pile for the building. There is some settlement because of the fill material itself. So it means that we fill up the soil in order that we can be above the maximum flood level. If we fill more, if you settle more, in some year it may be lower than the flood level, and then we fill again. And besides, in the past we use the underground water, so we do groundwater pumping, so there might be some subsidence that occur in the area. But of course, thanks to everybody that stopped the groundwater pumping in Bangkok, so we have no more subsidence in the city center of Bangkok, but we still have the settlement or subsidence from the filling soil. will excavate quite near to the sand layer, but not get into the sand layer, because in sand layer there is a groundwater. There will be a boiling or the water that flow into this pit. When we start to excavate, the more grow in Bangkok, the more excavation pit is occur, and then the more accident like this happen. The excavation pit slide and then causing the damage like this to the property, to the life of the people. It's not only the problem of the safety, but the problem of the environment that even more complex than that. After the excavation pit has done, so you totally lost the use of the land in this area because of water level is low. There is some sliding down. You can see houses flowing into this 21st December last year. That's the problem of the excavation pit. The new owner that bought this area or this lake start to filling in the soil into the lake and start to do the project of the housing project. This is the lake, and then this is the soil that I fill in, very new deposit. I used to do some small mock-up, small setup research that we fill in the crushed rock over the area that is unimproved, the area of the pond that is just filled in. I realize this. This is what, and then we put some monitoring in the area, and then this is what we found. And this is what happened to some project that did not concern or did not realize that they are building the housing over a very soft area. This area used to be a big pond. This is the elevation of the parking in this house. When time passed by, the settlement of the road, which is on ground, is settled a lot. And even another problem with this kind of thing is because of you have the fill material over a very soft area, very soft soil. There's a possibility of what we call the negative skin friction. And finally, the house can collapse like this. So that's a problem that we pose, that we try to make use of a newly filled pond, and then large sediment occur and then has a problem. So in the past few years, my research have done a lot about the vacuum consolidation. We try to avoid the large sediment of this kind of pond by using the vacuum to drain the water out and try to consolidate the soil before the actual construction will be put the load in. This is the system of the vacuum consolidation. This is the example of the project that this used to be a big lake. This is Ajahn Prinitik, and this is the membrane. This is the standard for filling and compaction of the soil, and then there are special sections for the housing project. But I like to conclude my presentation here. Improper development causing social problem. As a civil engineer, you always need to think of this one. Engineering solution may solve one problem, but created many. When you think that your solution is good, you go ahead with this solution, but you need to think that you may solve one problem, but in the future, maybe there might be some other problem relating from what you try to solve the problem. Engineering may serve social demand. So as created social problem, we try to fill in the soil, we try to excavate, we use our profession to calculate what will be the safety of the excavation slope. But we need to think more and more that if we do that, what would be the next social problem that is going to occur? Looping can stop if one have thought it thoroughly and truly. This is very important. As an engineer, you have a big responsibility for your social, not only the social society in your country, but also all around the world. And I like to end up with the meaning of civil engineer. Civil engineering profession, what it is. We are the profession that harnessing the resources of nature for the benefit of mankind. We use our knowledge, we use our standard, we use our practice and experience to help to make use resources of the nature for the make best benefit to the mankind. You need to keep in mind, this is our profession. Thank you very much.